There's a fascinating story which is captured in the movie Longitude, or actually a series the BBC did about 20 years ago. And it's about how a watchmaker in the 18th century in England created a watch that allowed the British Navy to assess their longitude on ship voyages. Now, for technicalities, the longitude is when you go east-west. So you start in Plymouth and you go towards Jamaica, and you need to know exactly where you are towards the west. The north-south is easier to measure because you have geometry, equator, and the sun, and things like that, sextants, that allow you to assess where exactly you are on the north-south trajectory. But the longitude was a problem, a difficult problem to solve for the British Navy. And the movie shows the history of the watchmaker who actually delivers the result. I'm going to talk about that. The reason I want to talk about this movie, other than it's a great movie, Jeremy Irons plays a person that about 150 years after William Harrison, who is the watchmaker, that he is one of those researchers who digs in, reconstructs the timepieces that were made, and sort of becomes a scientific communicator. Something maybe like today would be Sean Carroll or those types. And so the movie goes back and forth. Really great movie, I think, very interesting. So what it shows is one thing that made me think, and it shows how reluctant the establishment was to accept this new technology. And it reminds me a little bit of today's FSD, autonomous driving situation, where the regulators are pushing back the timeline to win time for themselves and also for competition, whether that's corruption, whether that is just inertia, that that's not so clear. In the movie, it's not clear either, but it just shows how with pedantries and scientific details and data dump type strategies, you can keep a technology, in this case, for decades away from practicality. Hopefully this doesn't happen today with autonomous driving. This is not Imran podcast. It's March 13, 2026. This is Crimdalco. For the year, we're down 12.3%. The market is down 2.5%. We're underperforming by 9.8%. So the movie Longitude shows the story of William Harrison, who is a watchmaker. Now, I'm not sure if William is his son or the watchmaker, but anyway, the Harrison watch, which is a watch that works precisely and most importantly, works on a ship. In those days, we're talking sort of mid-1800s, watches were all driven by pendulums. So it was the pendulum swing which made the watch work. And the problem of ships was that the moving of the ship changed the pendulum and therefore made it very difficult to have a very precise watch. And what Harrison did, he constructed a massive mechanic monster that was able to offset the shaking of the ship and keep the pendulum isolated from those shakings. Because what you want is you want to have a harmonic oscillator. You want to have an oscillator that is independent of its environment. So very similar to, for example, quantum computing today, where you want to have the oscillation of the wave function independent of the environment. You don't want to have decoherence. So in that sense, Harrison was maybe the first, the first such attempt, at least to our knowledge. Now, the way you assess the longitude on a ship is you have a time difference between where you are and the time in Greenwich. The time in Greenwich, which is the zero longitude meridian, it is let's call it just the reference time, and you set your clock to the time in Greenwich. Now, let's say you're on a ship and that clock keeps ticking and you're like, call it, 500 miles west. You can then assess precisely noon by using a sextant and the sun and the orthogonal situation of the sun. So those applications were possible. And now you can say, okay, we are at noon, but the clock, which is ticking at Greenwich time, is showing 10 a.m. So you're 2 hours ahead now, and that it was already known back then that every, 15 minutes, you gain a certain amount of miles going west. So you could then calculate your longitude. So the whole game here was to have a precise watch that can mimic the time in Greenwich, and of course, the ability to precisely determine the local time using geometry and the sun. So that was the technology, and the goal was, of course, to have a clock that is precise. And having a precise clock required first having a precise clock period. I mean, that's something that the Swiss watchmakers, for example, have been nurturing for centuries, and also, British watchmakers were nurturing. But then the second problem that Harrison solved, and that was the much bigger problem, was how can you undo decoherence? That was the really big problem, because on a ship you have waves that sort of counterbalance the pendulum, and that was the big innovation. How exactly he did it, the movie doesn't even show it that much. I think you need to read a specific book. I actually heard about it in the book, The Perfectionists, really nice book about the history of engineering and perfection. Links in the show notes. I spoke about the book recently, so you can check also our episodes. So I wanted to say a few things that struck me in the movie that remind me of today. And one was there was something called the Longitude Board, which was a board established by the king whose job it was to find a solution for the longitude problem and award the person that delivers the solution 20,000 pounds, which probably is something in the millions and millions of dollars today, in today's money. So big prize, makes you wealthy, makes you independently wealthy for the rest of your life. And the board, this longitude board, was really dragging their feet. And the way they did it is they first questioned, of course, the viability of Harrison's methodology. And then they had him go and test it, which is reasonable. But then after they tested it, and after they successfully voyaged and had also witnesses and captains of the ships and so on forth witness that this actually worked, the longitude board started using detailed data dumps. So they wanted this and that, and experiments and reconstruction and all kinds of time-consuming details under the guise of, well, this is science, it has to be rigorous, it has to be precise. And Harrison, several times in the movie, the person that plays Harrison, the character, he says, look, you guys don't have a good solution right now. Why are you dragging your feet? We have a solution that works. We can save lives. Please let me deploy this, and then you can give me the prize. And then if it doesn't work, it's fine. I'll maybe give me half the money or something like that. But clearly, the institutional stalling is very prevalent in the movie. And it reminds me of today how full self-driving Tesla's technology is being stalled by the regulators around the world. Particularly the US regulator now wants more data. The Europeans want more data. The Chinese are not happy with the data. So everybody's sort of now starting with pedantries and trying to stall the adoption of full self-driving unsupervised, which of course, for all of us who actually use the technology, we already know it is much, much better than human driving, and it should be deployed at scale globally because it would save lives. But it would also, of course, change the nature of the industry. It would hurt the OEMs. It would, make Tesla pretty much a monopolist, because it is very, very difficult for people to catch up for various reasons. That's for another episode. But this is just not the kind of technology where people can catch up. So what they're now doing is gaining time, because competitors are just saying, look, just give us enough time. And quite frankly, if you have enough training data and you can steal enough engineers from Tesla, you might actually be able to replicate the technology at some point. But again, I mean, this is of course also a moving target where Tesla itself is continuously improving and using more reasoning methodology, converging with graph. So it is virtually impossible to catch up with Tesla, but maybe at some point companies could have a viable technology that at least works as well as maybe Tesla 2 years ago, which is fine at least for safety reasons, certainly not for consumer reasons, because at that point most consumers would want the state of the art, which is Tesla. So to summarize, I think the movie Longitude shows very nicely how institutional barriers can be implemented, particularly the barriers or the sort of merchants of doubt that, well, we need more data, it's not clear, this is not clear. So you can you can ask for more data ad infinitum. The problem is, of course, they don't have an interest to launch this technology, to have it launched. Tesla is fighting this game right now. They're doing it sort of 2 steps ahead, 1 step back, because they don't want to push it too far. Accidents can have bad press and things like that. But they also need to keep the pressure on the pulse. And I think the best way to do it, and that's something that luxury Harrison didn't have, it is to play the constituencies against each other. Harrison was basically exposed to the admiralty of the crown. So there was one customer that was willing to even entertain this technology. Here we have many different municipalities, different countries, different cities within the US and also outside of the US. Like when I said different countries, I mean, let's say the UAE or there's European countries and cities that want to deploy this technology. It's not just safer for normal drivers, it also allows for example, disabled people, older people, younger people. I mean, it's just in any which way you look at it, it is a better technology. And when you do good things in life, eventually you win. The same happened to Harrison, and the same is going to happen to Tesla. Thank you.